with DD2
Okay.
though.
Notes from Friday. Last problem. Says a pizza with temperature of 95 degrees Celsius is put into a 25 degrees Celsius room when T equals 0. The pizza's temperature is decreasing at a rate of R of T equals 6 times e to the negative 0.1 T degrees Celsius per minute. Estimate the pizza's temperature when T equals 5 minutes. Any thoughts on how to set this up? Alright, let's do,
Is it like setting up the same as we did Friday?
yes,
Yeah.
let's do T of 5. Why do we want to choose T?
Temperature.
Alright, keep going, Rachel.
25 minus, not 25, is it 0 or is it 95?
95.
Okay,
95, but 1
And why is it 95?
that's the original temperature.
That's the original temperature.
Oh.
What does 25 degrees Celsius represent?
0. I don't know.
What's 25 degrees Celsius represent?
Oh, that's the
Temperature of the room. What is it I'm trying to find? The temperature of what?
Pizza.
Pizza, and that's what 95 degrees is. So that's why I'm not using 25. Alright, keep going.
From 0 to 5?
0 to 5. Of what?
60.
6 times e to the negative 0.1 t dt. Now that is very close, but it's slightly off.
Is it like
I said subtract. Why?
Oh.
Because I'm decreasing. My rate is decreasing. So you can do one of two things. You can make that subtraction, or I can put a negative in there on my rate. That's what I'm going to do.
You're putting a negative
I'm putting a negative on the rate. So all I have to do is punch that in. Somebody punch that in for me. How do we get the integral symbol again?
Shift.
Shift plus, good.
.391.
And what are my units on this? Degrees Celsius. So 71.391 degrees Celsius. Now, Gregory, go back in there. Did you do the minus or did you do the negative in here?
I did minus.
All right, go back in there and change that minus to a plus and tell me what you get. Because I want to make a point about something.
Oh, it's 118.608.
All right, so what should have been a dead giveaway that this right here was no good?
It's outside there.
My original temperature is 95 degrees, and what's supposed to be happening to my temperature? It's supposed to be decreasing. That got larger. So if I did it without the negative or the minus, I would have got that, and then that should have told me, oh, it's decreasing, so it needs to be negative. So that's why we get 71.391 degrees Celsius. All right. Questions from Friday's assignment? Is this it? This is correct worksheet.
Yeah. Yes.
5?
Yes.
5. A particle moving along the x-axis has position x of t at time t with the velocity of the particle v of t equals 5 times sine of t squared. At time t equals 6, the particle's position is 4, 0. Find the position of the particle when t equals 7. So what is it I need to find? you say, Zach?
X of 7.
I need to find x of 7. It wants the position when t equals 7. And it says right here that position is x of t. Alright, Hunter, set it up for me to find that.
4 plus the integrals from 6 to 7, 5 sine of t squared dt.
Perfect. Now, why do I not care about that 0 in that ordered pair? Because I'm doing what? I'm dealing, it's moving along the x-axis. So every point, what's the y value going to be for every point? Every point, the y value is going to be 0. Did somebody punch this in for me? What'd you get, Gage?
3.87. 3.837.
3.837. Anybody verify that? Okay. Anything else from Friday's assignment? 11. And a lot of you are getting tripped up on this estimation stuff. You guys are trying to get an exact number instead of just going with the flow. It says the graph on the right shows the rate of change of the quantity of water in the water tower in liters per day during the month of April. If the tower has 12,000 liters of water in it on April 1st, then estimate the quantity of water in the tower on April 30th. So we're looking at the graph of a rate in liters per day, and I'm interested in finding what? Just the liters. So what do I have to do to liters per day? I've got to integrate liters per day.
Wait. Oh.
And it didn't name it. So since it's a rate, I'll call it R of T. Alright, so do I need to put anything in front of it?
Yeah.
What needs to go in front?
12,000.
12,000. Now, I've banged in your head over and over again what are the two things that represents?
Net area.
Area of the curve,
And net change in
net change in the function above. If I've got a graph, which one of those two we're going to do?
area.
We're going to do area on the curve. So, I'm just going to do my best estimate at the area. So, I need that area. And I need that area. Alright, now, each rectangle is worth how much? $300. Somebody besides Zach, tell me why each little rectangle is worth 300. Yeah, there's 6 wide and 50 tall. So all I've got to do is add up all those, or estimate each one of those, and then add it to my 12,000. Right? So let's start with the first one. If I look at that, that's very, very close. That's very, very close to that triangle right there. So I'm going to use that triangle to estimate. So area of a triangle is 1/2 base times height. What's the base?
2.
12. The height? 50. So 12 times 50 gives me 600. Divide that by 2. 300. So I'm going to call that negative 300. Then I move over to the positive part. On the positive part, I'm going to start with that section first. What's the area of that rectangle? 12 by 100, which gives me 1200. Alright, then it looks like I have another triangle right here. So that's a 6 by 100. 6 times 100 is 600 divided by 2. So that's going to be 300. And let's go with another triangle there and another triangle there. or I can just do the full triangle by itself. So if I do the full triangle, the width, or the base, 12, how tall? 50, 12 times 50, 600 divided by 2, 300, so another 300. So, 300, 300, that gives me 1,500. Oops.
Wait.
Alright, and Y is my units liters. I integrated what? What units did I integrate? Liters per day. So if I integrate liters per day, I'm going to get liters. Alright, let's move to today's stuff. I'll pass out a sheet here in a second.
That's close enough. It's close enough.
Thank you. Alright, we're doing some more of the same stuff we did on Friday. It's just going to look, the problem might look a little bit different, but it's all the same concept. So on the first one, it says if f of 3 equals 5, f prime is continuous, and the integral from 3 to 8 of f prime of x dx is 20, we want to figure out what f of 8 is. So what am I going to set up to find f of 8? Gregory, go ahead.
Be 5 plus integral 3 to 8 of f prime dx. Which equals 25.
Alright, so there's that, and it tells me that this is equal to 20, so that means f of 8 is equal to 25. Any issues there? Pretty straightforward. Alright, next one. It says if the integral from -1 to 4 of 3 times f of x plus 2 dx is equal to 28, we want to figure out what the integral from -1 of f of x dx equals. So this one we're not really using Friday stuff, we're just using the properties of definite integrals. So any thoughts on how we're going to figure out what the integral from -1 to 4 of f of x dx is? Split it up is correct. So I'll move that 3 to the front, and I give 2 its own integral. Alright, Gabriel, what do you think's next? Caleb, what do you think?
Would you divide the 2?
I can't divide the 2. Alright, so what do you think? Alright, I could divide by 3, but I don't want to do that just yet. Hannah, what do you think? Hannah, what do you think? All right, what do you got, Tio?
Take the integral of 2.
And what do you get when you do that?
10.
10. Very good.
Oh, yeah, because
So this right here turns into 10. You understand why that turns into? Excuse me. Turns into 10. Yes. How far is it from -1 to 4? 5, and 5 times 2 gives me 10. So now we're getting somewhere. Let's do 2 things in the next step. What 2 things do we want to do to get that by itself?
Minus 10 divided by 3.
Subtract 10 divided by 3. Alright, so if I subtract 10, that's 18. I divide by 3. That means the integral from -1 to 4 of f of x dx is equal to 6.
Okay, then we have piecewise.
Alright, last one on the note sheet, and then we're going to hand out the assignment. We'll do the first one on the assignment together. Alright, so this one,
Piecewise.
what type of function is that? Piecewise. So f of x is equal to 3x minus 1 when x is less than or equal to 2, and it's equal to x squared plus 1 when x is greater than 2. We want to evaluate -1 to 4 of f of x dx. Gregory, what do you think?
Integrate the top and bottom.
Hunter, what do you think?
I'm not sure.
Gage?
Well, I mean, I think you'd have to do something when it's less than or equal to 2 and greater than 2, but the interval goes to both.
So what do you want to do?
I don't know.
Gabriel, what do you want to do?
Trying to get to an absolute value.
I don't want to turn it into the absolute value, but it's similar. It's already, the absolute value, what do we take the absolute value, turn it into a piecewise, and then what do we do? Then we have 2 separate integrals that we work separately.
-1 and 2.
Same thing here. So we're going to start at -1, and the first one's going to go from -1 to where? 2. And what function needs to be inside there? 3x minus 1. Then the second one's going to go from 2 to 4, and what function needs to be in there? X squared plus 1. Okay? Numbers between -1 and 2 fit that, so that's why 3x minus 1 is there. Numbers between 2 and 4 fit that, so that's why x squared plus 1 is there. Okay, you just split it up. Now we work each one of those separately. So if I integrate 3x, what do I get?
3x.
3x squared over 2, integrate 1, x, from -1 to 2, integrate x squared,
X cubed over 3.
x cubed over 3, integrate 1, x from 2 to 4. Now all I have to do is plug in and look it up. Alright, on my first one, from -1 to 2, which one do we plug in first? 2. So 2 squared is 4, 4 divided by 2 is 2, 2 times 3 gives me 6, then I plug in 2. Plug in -1, -1 squared is a positive 1, so this is 3 over 2. Plug in -1, that's going to make that a positive 1. So this right here comes from that. Plus, plug in 4, that's 64 over 3. Plug in 4. Plug in 2, that's 8 over 3. And 2. So all of this came from that. Now I put my like terms together. So 6 minus 2 is 4, minus 3 halves, minus 1, plus 64 over 3, plus 4, minus 8 thirds, minus 2. Alright, so 4 and the -1 is 3, 3 and 4 is 7, 7 and -2 gives me 5. So that's gone. Then I have 64 thirds. Was this a positive or negative on the 8 thirds? Negative? So 64 over 3 minus 8 over 3. 56 over 3. And then I had the minus 3 halves. So what's my common on there need to be? 6. Alright, so the numerator of my first fraction is going to be 30. Second fraction, and then 112. And my last one, 9. So 30 and 112 gives me 142, 133. So we end up with 133 over 6. Alright, pass those out for me, there's 2 sheets. Alright, we'll do the first one on the worksheet, and then we'll cut you loose to work.
Okay.
Thank you. Alright, so it says the graph of function f consists of a semicircle and 2 line segments as shown. Let g be the function defined by g of x equals the integral from 0 to x of f of t. So, what is the relationship between f of t and g of x? What did you say? G of x.
Like, I don't know how to describe it. I'm
Here,
not
let me ask you
Oh,
this. What can I do? What can I do to get rid of that integral? Take the derivative of it. So if I take the derivative of both sides, I have d over dx of g of x equals the derivative of the integral from 0 to x of f of t dt. So this over here on the left is g prime x. What do I get on the right?
Just f of t.
I don't get f of t.
Oh, yeah.
I get f of x. Remember what theorem am I using?
Oh, yeah.
Second fundamental theorem of calculus. What 2 steps does the second fundamental theorem of calculus tell me to do? What's step 1? See, this is what I told you guys. I told you guys you're going to take something that's the easiest thing to do all year and then you're going to make it hard.
Okay.
Plug in. Thank you. First thing you do is plug in. So I plug in, that's where f of x comes from. And then step 2, in this case I didn't have to show it, but what's step 2?
F of 0.
What's step 2?
Show it the derivative, is it multiplied by the derivative?
Multiply by the derivative of what you're plugging in. So in this case, it's multiplied by 1. So we have learned that g prime of x is equal to f of x. So I have the graph of f, which means I also have the graph of what? What we just proved. This is also the graph of g prime. Okay. Alright. That doesn't really come into play until we get to B and on. You can do the first part without knowing that, but we need to know that. Alright, so g of 0. What do I do to find g of 0? Come on, people, don't make this hard, please. Plug in 0 for x. And what do I get when I plug in 0 for x? I get 0. Why is it 0? My integral did not change. I went from 0 to 0, which means it's always going to be 0. Alright, next thing, g of 3. So G of 3, what's that going to look like? 0 and 3, good. Alright. So again, if I have a graph, what am I going to do to figure out what that equals?
Look at area.
I'm going to get area, and I need the area from 0 to 3. So the first part of that area, is a quarter circle. How do you find the area of a quarter circle? 1/4 pi r squared. 1/4 pi, what's my r in this case? 2 squared. Then the other part is underneath, so I need to subtract that. It's a triangle. What are the dimensions of that triangle? 1 by 1, so 1 times 1 times 1/2 gives me 1/2. So that means this ends up being what?
Oh. Pi minus 1/2.
Pi minus 1/2, good. Pi minus 1/2. Next one, g of -2. So I want the integral from -2 to 0. No, sorry.
No. 0.
It has to start out as 0 to -2, but we don't like that. What do we want to do? Flip it. Make it negative.
Well,
So negative -2 of f of t dt. So 0 to, or -2 to 0, we should know already that that's equal to pi. So that means we get negative pi out of that. And then g of 5, integral from 0 to 5 of f of t dt. What do I already know? I already know 0 to 3 is pi minus 1/2. So then I just need 3 to 5. What do you notice about the areas on 3 to 5?
There, those cancels.
They cancel each other out. So that means g of 5 and g of 3 are the same value. Alright, so any questions on finding those function values? Rachel? Good? Alright, next one. Next one says find all values of x on the open interval between -2 and 5 for which g has a relative max. Justify your answers. So what graph am I looking at again? G prime. How do I use G prime to find a max? G prime has to change from positive to negative. So where does that occur?
2.
At 2. Now, we've established that f is the same thing as G prime, but if they give you a graph and label it f, then you want to call it f when you use it. So I want to say I have a maximum at x equals 2 because why? F changes from positive to negative. So that's what I want on B. Relative max at x equals 2 because f changes from positive to negative. If you do what we did earlier and show that G prime is equal to f, then you can use G prime, but I would stay away from that if at all possible, just to be safe. Alright, part C, absolute minimum value of G on the closed interval from -2 to 5 and the value of x at which it occurs. So absolute minimum, how do we find absolute extrema? Or where do we look?
Endpoints and critical points.
Endpoints and critical points. So what are my endpoints in this case?
-2 and 5.
-2 and 5. I've already figured those up. G of -2 was what?
Negative
pi. And G of 5 we figured was pi minus 1/2. Is that correct?
Yeah.
Okay. So if I'm looking for an absolute minimum, what else do I need to consider?
Critical points.
Critical points. Where are my critical points?
2.
2 and 4. But I really only need to consider 4. Why do I not need to consider 2?
It's a relative maximum.
Because we already said on part B that I have a maximum there, a relative max. A relative max can never be an absolute min. So therefore, I just need that. Did we figure out what G of 4 was?
No.
No. Okay, so I need the integral from 0 to 4 of f of t dt. What did I already figure out in that interval? 0 to 3 was what?
I minus 1.
Pi minus 1/2. So then I just need to go one more step. What else do I need to put with that to get G of 4? Another minus 1/2. So that means we get pi minus 1. So I'm looking for the absolute minimum. Where's the absolute minimum, or what is the absolute minimum, and where does it occur?
Oh.
Negative pi, and it occurs at
Negative 2.
-2. Now it says justify your answer. What do I do to justify my answer? What?
Is
What did you
it
say,
your
Zach?
work? Is it your work?
It is my work. It's a trick question. Remember, on absolute extrema, your work is your justification. That's the only time. So, absolute minimum is negative pi, and it occurs at x equals -2. All right, next one. Oops, I did not mean to do that. Next one says, write an equation for the line tangent to the graph of g at x equals 3. We should be pros at that.
Sure, pardon this interruption. JD Moore, if you are in the building, please come to the main office. JD Moore, if you're in the building, please come to the main office.
All right, so x equals 3, so I know 3 has to go there. What's the y value that goes with 3?
I minus 1.
Pi minus 1/2. We figured that out already. Put that in parentheses. So what's the only thing left?
Slope.
The slope. Where do we get slope from?
Derivative.
The derivative. So in this case, I'm running a tangent line for the graph of g, so that means I need to figure out what g prime of 3 is. G prime of 3 is the same thing as f of 3. What is f of 3 on that graph?
-1.
-1. There it is. So there's my tangent line equation. All right, is there another one? Another question down there as well?
Yeah.
Oh, 2 more?
Some more.
All right, x coordinate the point of inflection of the graph of g between -2 and 5. So we ought to be able to knock this out. That's a review. Where are the points of inflection at and why?
It changes from
What does? Quit saying it.
when f changes from
Keep going.
when it changes from increasing to
You said
decreasing.
it again.
When the f changes from increasing to decreasing.
When the f changes from increasing to decreasing or
Decreasing.
decreasing to increasing. So where are my points of inflection at?
0.
3.
0 and 3. So points of inflection at x equals 0 and 3 because f changes from increasing to decreasing or vice versa. And the range of g. So what do I need in order to get the range of g? I've already got one of them.
Absolute max.
I need the absolute max and the absolute min. What did we say the min was?
Negative pi.
Negative pi. Okay, so negative pi is going to be the bottom of the range. And now I need to know the top of the range, which means I have to find what? Absolute max. So we already found g of -2. We already found g of 5. What else do I need to find that I haven't found yet?
That's it.
I need g of 2. What do I need g of 2? What is g? It's a maximum. What type of maximum?
Relative max.
Relative maximum. All right, what did we say -2 was?
Negative
Negative pi?
pi.
Yes.
All right, 5 we said was pi minus 1/2. And g of 2 should be pretty easy to get. What's g of 2 going to be? G of 2 is going to be pi, because that's just that quarter circle. We already figured out that quarter circle was worth pi. So that means my range is going to go from negative pi to what?
Pi.
To positive pi. So there's my range. The lowest you can be is negative pi, highest you can be is pi. Alright, there it is. Get to work.
Oh my.